Okay, hey everyone. In this example, we are going to solve this circuit here, looking for the value of V naught at this node, and we're also going to calculate the power dissipated by each resistor. So I'll quickly flash the solution here. This is the solved circuit. I just used K-circuit for this. It's the same circuit as you saw, but now all the voltages at each node are shown, as well as the current that's traveling across each circuit element. So now let's actually do this on our own. So it says find V naught and the power dissipated in each resistor. So we have options for doing this. We can use mesh analysis, nodal analysis, whatever we want. So I'm actually going to choose mesh analysis for us. So there's one, there's two. Yeah, let's do mesh. So we'll call this one I1, and we'll also do we'll do this again as nodal at the end, so we get some extra practice. So here's I1, there's I2, those are our mesh currents. Now we'll write out the expressions for each loop. So for I1, it goes through the minus 60 volts first, and then it goes through the 12 ohm resistor. So 12 times I1, and then it goes through this 10 ohm resistor here. So 10 times I1 minus I2, because with respect to the I1 loop, I2 is going in the opposite direction. So that's why there's that negative sign there. And then with all KVL expressions, we set that equal to 0. Do the same thing now for I2. So for I2, let's start with the 10 ohm resistor. So there's the 10 ohm resistor, there's the I2, minus I1. So it's just like what we saw earlier, but now with respect to the I2 loop, I1 is in the opposite direction. So just to make sure it's clear what I'm talking about here when I say opposite direction, I2 goes across the 10 ohm resistor from bottom to top, whereas I1 is going from top to bottom. So check out these current directions. This is clockwise, goes from top to bottom. Let's get rid of that now. Oops. Undo, undo, undo. Okay, and then I2, follow that direction, or that arrow. It's going clockwise, so it goes from bottom to top. Alright, so let's come back down here. We did the 10 ohm resistor. Let's do the 6 ohm resistor. We'll use the blue pen. So plus the 6 ohm resistor times I2, and then minus 24. That's equal to 0. So notice I said minus, and that's because it goes through the negative terminal first. If it had gone through the positive terminal first, then you would have put positive or plus 24. Notice that the same thing happened here in the I1 loop. It went through the negative terminal first. That's why you got negative 60. Anyway, now we have two equations. Let's tally up the unknowns. It's I1 and I2. I'm not going to highlight this again because we already highlighted that. Same thing down here. All these have been highlighted once already. So there are two equations, two unknowns. This can be solved in MATLAB, Python, your favorite program, and you'll solve and you'll figure out what I1 and I2 are. So now let's write an expression for V naught. So V naught, I think you would agree with me. So let me add an auxiliary current here. I'm going to call this I3. So I3 is the total current going across the 10 ohm resistor from top to bottom. So I can write an expression for that. I3 is actually going to be equal to I1 minus I2. And the reason why I write it that way is because I1 is in the same direction as I3. I2 is in the opposite direction of I3. So to extend this loop a little bit so it's more clear, opposite direction. So now we have an expression for I3. So let's grab that. So V naught, my claim, is that V naught can be computed using Ohm's law. So V naught is equal to IR by Ohm's law, so I3 times 10. And you know what I3 is. So now you have V naught. Now if you want the power through each resistor, all you need to do is use one of three equations that we have for power. So there's I squared R, there is V squared over R, there's also I times V, or V times I. So you have three choices. Ultimately, if I have current, and I'm all set, and I do have current. I know what I1 is, I know what I2 is, I also know what I3 is. So for example, if I want the power across the 12 ohm resistor, I'm going to use this expression here. I'm going to do the current through the 12 ohm resistor, which in this case is I1, and multiply that by the 12 ohm resistor. Remember to square that current, by the way. And then you'll be done. You would have the answer for the power across the 12 ohm resistor going from left to right. Let's do the same thing for the 10 ohm resistor. That would just be I3 squared times 10. And then finally, for the 6 ohm resistor, it would be the I2, because I2, that's the current going across the 6 ohm resistor. And then times, I think resistance should say 6, so let's put that in there. Okay. Alright, and the idea is you solve all this in MATLAB or Python, and you'll get your final answers, and then you can compare them to what's here. So again, this is showing you the current in each branch. So you can see the 4.47, you can see this 0.2857, etc. So with respect to this, you can calculate the power yourself by multiplying I squared R just like we did, or you can just compare the values of the currents that you get when you solve these series of equations here, these two specifically. Alright, thanks.